quick recap. If we have this, what do we have for velocity? Must be positive and constant, which means this must be 0. So straight line turns into a flat line turns into a 0. If I have this, flat line turns into a 0, which is still a 0. And I'm laying them on top so you can see it. Okay? How about a curved line? I'm accelerating. It's positive change, so my line's going to be positive. If that's positive, then my acceleration must be positive. And we're going to pretend those are straight lines. Okay? So now let's look at what if we slow down. We're going to slow down. So this time the curve is going to be that one, which means the acceleration is going to be negative. So now let's talk about the forces again. Red line, what's the net force on it? Constant velocity, acceleration is 0, so the net force must be 0. The orange line, constant positive, straight, acceleration must be positive, so the net force must be positive. Try the green one. Try it on your own real quick, and then you can check it. Outward curve, so it's the downward line, downward straight line, but that means the velocity, the acceleration is negative, which means the net force must be negative. What about the yellow line? So the yellow line is flat and unchanging. Velocity is 0, acceleration is 0, so the net force must also be 0. Let's try this one. Let's try this series. This time I'm gonna kind of throw them up there, and I want you to sketch the graphs and then tell me what it is, and then you can check your answer. Which one's going faster? A or B? And then sketch the two graphs and then tell me what the force is. Pause the video and do that for me. All right, so let's check our answer. So A is faster, so if we graph the velocity graph, A should be there, and then our letter B should be here. Now these are just sketches. I don't have numbers, so I'm just making a rough guess as to where they might be, okay? What's my acceleration for both of those? Both of those, the acceleration must be 0. Switch to the red. Both of those must be 0, which means the net force must be 0 for both of them. Net force for both is 0. Okay, let's try another one. Same situation. Orange is letter B and red is letter A. Which one has a greater acceleration? Try it on your own if you need to first, and then let's take a look. They're both going to have a changing slope, but the red one is a flatter circle. So the one is steeper than the other. So the flatter circle is going to have a shallower change. It's going to have a smaller velocity graph, and then their orange one has a steeper, sharper curve, a steeper curve. So the velocity graph is going to be steeper if you calculate the slope. So now let's look at if I were to take the slope of those, which acceleration is faster? Which one is accelerating faster? Well, the orange one should be on top and the red one should be underneath, but they are both positive. If they're both positive, what should the net force on both of those be? The net force should be positive. We can't know the number unless we are given numbers in the problem. We would have to know the math, so we'd actually have to know the actual value for acceleration, but there you go. Okay, let's try one more, and then we will try something a little more complicated. Okay, so let's try this one. Red is A, orange is B, and yellow is C. So which one of those is constant speed? So the answer is A and C, constant speed. Which one of those is accelerating? It's letter B, because it's a curved line. That's all you know that just by looking at your distance versus time graph. Okay, what's the velocity graph going to look like for each one of those? So the first one is A, or C is the yellow line, and it's angled and it's straight, so the other one must be flat. It is a positive change, so we're going to have a positive velocity. And then the red one is flat, so the next one must be 0, so it's at rest. Velocity is 0. And then we have our last one, which is the orange one, and it is accelerating, so there must be a changing velocity. Okay, so you may have to match which one goes with which one on your test. So A goes with the bottom one, B goes with the orange one, and then C would be the other yellow one. And now let's do the acceleration graph. So we are on orange. Orange is positive, so the acceleration will be positive. And then red and yellow are both flat lines, so those both must be 0. So red and yellow must have 0 net force, while the orange one must have a positive net force. Okay, so next we're going to look at putting all of these graphs together to describe complex motion that's all happening together. And we've kind of seen this in our gizmo in our labs, but we're going to start off with the car. It's at a stoplight and it's going to accelerate. It's going to get faster and faster. But once you get to the speed you want, you maintain the constant speed. So this is a straight line here. But then I see a stoplight or an accident up ahead and I want to slow down. So I'm going to slow down. So my curve turns into an outside curve. And then I need to stop. So I actually come to rest. See how this is a flat line. So this is all distance versus time. So we're accelerating, constant speed, decelerating, and then at rest. And when we give this to you on a test, we'll probably have each area marked with a letter, and then you're going to have to come over here and you're going to have to tell us which one is which. So which one is accelerating? Letter A is accelerating. Which one is constant speed? Letter B. Which one is negative acceleration? Letter C. And which one's at rest? Letter D. From that, you should be able to map the velocity graph as well. So acceleration, constant positive speed, slowing down, and then we're at rest. Okay, so they describe the same motion. So this is accelerating, constant positive speed, we're moving. So this might be, we're going faster and faster and faster. We get to our speed. Now we're going to slow down, and now we're stopped at a rest. Let's do another one of these, and then you will have time to practice on your own. Okay, so these can get a little tricky to determine where things are at on the graph, but let's take a look at this and we're going to try to sketch the velocity graph. So I want to explain it real quick, and then I want you to try to sketch it on your own. But you have to read real carefully where the time interval is, but you can see obviously right here, there was definitely a change in the distance graph. So this is one type of motion. This is one type of motion. The curved lines is where it gets kind of hard to determine, but usually there will be a letter choice. So this letter choice is actually for the curved line. And then we have this straight line, okay? So with that said, I want you to try to determine which ones are constant speed, whether it's at rest, whether it's accelerating, whether it's not negative or positive, and what the velocity is. See if you can draw that one. Pause the video, and then we will check it real quick. Okay, welcome back. So let's check what we got for our graph. So this first one is negative going down, but it's a straight line. So if it's negative going down, that means the next one must be flat, but it's negative, so it's going to be down here underneath. Okay. The next one is at rest, so letter B is at rest. So that means the velocity must be 0. So it's like instantaneous, okay? We're just stopping in an instant, okay? So we're at rest for that section, but then we accelerate. So now we're going like this on a curve. It's pointing up, it's positive. So we're going to have our velocity go positive. And then we have our distance graph, which is at a straight line and is going to be flat. So the key is being able to look at the graph and just look at the section you're thinking about. And that can be hard to do on the computer because on paper, you can usually cover up the graph. You can cover up the parts you don't want with like pieces of paper. And you can go, okay, that part is accelerating, and you can draw that part. So like letter C is curving up. So the velocity for letter C is constant and positive. Okay, so if it's straight, it's constant, okay? If it's pointing up, it's positive. If it's pointing down, it's negative. If it's curved, it's increasing at an increasing rate, and it's pointing up, it's gonna have a positive velocity. That's gonna be straight in the next graph, and then the acceleration will be positive. That's a lot. But I hope that that puts everything we've been kind of talking about together in one big picture. And so what I want you to do is you have some homework problems to practice this some more. And if you have any questions, please ask in your class. And we'll see you in the next video. Thank you. Bye.